Okay.
Now it's changed from render window to follow Sim2. Reading the data.
So it's sending from this end fine.
Can you pause the map and go to the next slot? It starts going to the next position. And it reads the data.
Where did that one Arduino code? Oh, I closed the Arduino code.
Stop processing and plot it. You plot it and it completes the map.
Okay. I'm gonna do a thing. What? I'm gonna do a thing.
Next
What do we do?
So right now I'm going to demo the waveform propagation, aka grass fire expansion expanding algorithm here. So this is the Azimuth GUI I'm using, and I'm going to fire it up. So this would be the GUI I'm using that when in the real demo we can connect the laptop to the Azimuth robot. If we type in the port number here, so it can be connected to the robot, and it will do a bi-direction communication. And for the demo, we are required to do a path planning for two different types of maps. The first one is occupancy map, and the second one is the topological map. So for the occupancy map, this is one example of occupancy map. So we can see this map only have two different numbers, either 99 or 0. And the 99 represents a wall, and the 0 represents there's no wall. So here I create a layout for this occupancy maps for better visualization for the reader here. And this map is a topological map, and we can see the different type of numbers here, and there is a topological map coding here. Like 0 to 15 is representing different types of wall locations, and the location will be showing in this column here. So I use this topological map coding and to apply to this topological map, so we get this map here for better visualization. So for the first situation, occupancy map, we can have a start position and end position in the Haoxuan MATLAB GUI here. So if we type in a start position here, as I use in the map, I use 1, 3 for my start location and 3, 2 as my end position. So 1 is the first row and 3 is the third column. This 3, 2 means the third row and the second column. And as for the heading, we know the robot will start going to the right at the beginning. So I will place my robot towards the right. And here I'm using 3, 0, 1, 2, 3. This stands for up, left, down, right. So here it will be 3. And then we can use occupancy, calculate the occupancy grid here to see the results. It will be shown to the MATLAB command window here. So we can see that's the same occupancy grid we used before, and this number, the smallest number, 1 here is the angle as I showed in the PowerPoint here, it's 3, 2, and 1, 3 is the biggest number in the map, 6. So the grass fire, as the name suggests, it's like a grass fire. You fire from biggest number 6 to the 1. And here I'm using 4 connected grass fire instead of other like 8 connected or adaptive grass fire. And here we can see the robot should go to the turn right first, and then you go here and then turn right again, and then you reach 1. So there will be a T stop sign here. So this sequence will be sent to the robot and sent to the Haoxuan, and Haoxuan will follow this robot to run in the real map. As for the second topological map, so I also have this topological map built into this GUI, because the GUI will call function, and the function would take these 5 inputs and give out the results as the command to the robot. For example, right now I have 1, 4 as my example, 1, 4 as my start point for my example, and 4, 2 as the angle, because we know you pointing downwards, so it will be 2 in this case as my robot heading. And then we can calculate the topological grid. So what happened behind here, this GUI would call a function, and the function will take in all these inputs, and then it will convert the topological map into the occupancy grid map. Here you can see we have a lot of 99 and 0. That's because I'm converting the topological map into the occupancy grid, because my grass fire propagation algorithm was done in the occupancy grid instead of topological, because 1 to 15, 0 to 15, that's a lot of cases, so it's easier just to take charge of 0 or 99. And as we can see, our start point 16 is the biggest number, and 1 is the smallest number, and as we use the convention before, you go downwards, it will be like go straight because the robot is pointing downwards. It goes straight and then turn right and turn left and turn right again. That's the same as our command to the robot. T is the stop for the final point here. So when we go to the GUI here, the function will generate this sequence of command that will be sent to the robot, and when we click send occupancy grid or either send topological grid, it will send the command to the robot, and the robot will receive that information and react in the real life. And this would be our Asimo GUI, the other GUI we are using, and this was developed in the processing because algorithms developed in the MATLAB, so our team decided to develop a MATLAB GUI instead. And I think I can also show an example for different points to show the robustness of this algorithm here. So, for example, if we choose here as our start point, and here will be our endpoint. Of course, it's not 1, 4. It will be 2, 1 because the second row and the first column. It will be a third row and the second column. So, and this is a topological map. If we type in this value here, and it will be pointing upwards, that will be 0 for the heading. And if we calculate the topological map, and we can see the result here. So 11 here will be our start point. You will go straight. It would, because it will point upwards. So you will go turn right first, then turn right again, and you will reach the angle as T here. So you will stop. So SRT will be the command sent to the robot. I can also do a demo for a more complicated one, like if we move the endpoint to the 4-2 instead. So we can see would turn right, turn left, turn right, turn right, turn left, turn right. It's a lot of steps, and we can see how this thing would work. So it will be 2 points the same, but the end location will be 4-2. And when we calculate the topological grid, we can see the results in the command window. So our start point is 24 here. You follow this sequence here, and until the endpoint. And as I analyzed before, it's turn right, turn right, turn left, turn right, turn right, turn left, turn right, and it reaches the angle here. So it demonstrates that my classifier algorithm is very robust. And one more point I want to point out here, you can see the number 88 here. So I assign unused grid as 88 to avoid some issue, because I didn't assign 88 value here, it will become 0. And the classifier will be like it's like a fire burning to the lower number. So if I put a 0 here, it's possible, like in this case we can see 11 and 88, you go to this direction instead. So I decided to put a dummy number here. I decided to put a placeholder number here to hold place just in case this goes wrong. Alright. And this is our demo for the path planning